Welcome to this Functional Skills Level 2 Maths training video. This video contains information and guidance on Criterion 22. Calculate values of angles and/or coordinates with 2D and 3D shapes. At Level 2, and by the end of this session, you should be able to calculate the sum of angles in various shapes, measure angles using a protractor, and find missing coordinates of 3D shapes. Here are some key facts to help us calculate the sum of angles in different shapes. Let's start with triangles. A triangle has 3 sides and 3 angles. The sum of the interior angles of any triangle is always 180 degrees. There are different types of triangles and they each have different properties. For example, equilateral triangles have 3 equal angles. Each angle measures 60 degrees. Right-angled triangles all contain a right angle. The right angle will always measure 90 degrees. Isosceles triangles have 2 equal sides and, therefore, 2 equal angles. To calculate a missing angle in a triangle, you need to remember that the sum of the interior angles is always 180 degrees. Here are 2 steps you can follow to help you calculate the missing angles in a triangle. Step 1. Identify the known angle. Write down any angles that you already know. Step 2. Find the missing angle. Subtract the sum of the known angles from 180 degrees to find the missing angle. Let's look at an example. This is an isosceles triangle. We know this because it has 2 sides that are the same length. Step 1. Identify the known angles. We can see the value of one angle is 64 degrees. We need to subtract this from 180 degrees. 180 minus 68 equals 112. 112 is the combined total of the 2 other equal angles. The other 2 angles are equal. Therefore, we can divide 112 by 2 to find out what the value of angle Z is. 112 divided by 2 equals 56. Angle Z equals 56 degrees. In this example, the triangle is a right-angled triangle. We know this because of the square in the bottom left corner. If you see this square showing the angle of a shape, the angle is a right angle. Right angles always measure 90 degrees. To calculate angle F, we need to follow the steps we just learnt. Step 1. Identify the known angles. We know that the right angle measures 90 degrees. We know that angle E measures 35 degrees. We also know that the angles need to total 180 degrees. Step 2. Find the missing angle. To find the missing angle, we need to find the total of the known angles. 90 plus 35 equals 125. We can now subtract the value of these 2 angles to work out the missing angle. 180 minus 125 equals 55. The missing angle is 55 degrees. Now it's your turn. Calculate the value of the angles by following the steps. Remember, all the angles in a triangle must add up to 180 degrees. Pause the video while you work out the answers, then press play when you're ready to continue. Let's check your answers on the next slides. You will need to pause the video while you do this. Angle D is 40 degrees. Angle V is 18 degrees. angle S is 60 degrees. Here's an exam question. Pause the video while you calculate the value of angle X in this isosceles triangle. Press play when you're ready to continue. In this question, we have been provided with an isosceles triangle. This means we have two equal angles. The angle on the bottom left is 32 degrees, so the angle on the bottom right is also 32 degrees. We can now calculate the missing angle. 32 multiplied by 2 equals 64. 180 minus 64 equals 116. Angle X equals 116 degrees. Let's move on to calculating angles in quadrilaterals. Quadrilaterals have 4 sides and 4 angles that always add up to 360 degrees. In other words, the sum of the interior angles of any quadrilateral is always 360 degrees. Looking at the quadrilateral on screen, we can see that A plus B plus C plus D equals 360 degrees. Squares and rectangles always have 4 right angles. For other types of quadrilaterals, such as parallelograms, rhombuses or trapeziums, we will be given some angles and will need to find the missing angle. To do this, we can use the formula on screen. Let's look at an example. This quadrilateral does not have 4 equal angles. Use the formula to calculate the missing angle. First, we need to add up the angles we know. 57 plus 37 plus 123 equals 217 degrees. Remember that all the angles in a quadrilateral total 360 degrees. Therefore, to find the missing angle, we need to subtract the known angles from 360 degrees. 360 degrees minus 217 degrees equals 143 degrees. Now it's your turn. Calculate the missing angles in these quadrilaterals. Make sure you take your time when adding or subtracting and double-check you're working out. Pause the video while you calculate the answers, then press play when you're ready to check your answers. Let's check your responses. Did you get them right? Pause the video while you check your answers. The answer for question C is on the next slide. Here's the answer for question C. Pause the video while you check, then press play when you're ready to move on to polygons. Polygons are shapes with 3 or more straight sides or angles, although they typically have 5 or more. We can use the following formula to find the total of the interior angles. n minus 2 multiplied by 180. In this formula, n is the number of sides. Let's look at an example. This is a regular pentagon. It has 5 sides and angles. We know it is a regular shape because all the sides are the same length. This also means all the angles inside the pentagon will be the same. Let's use the formula to calculate the sum of the interior angles. 5 minus 2 multiplied by 180. 5 minus 2 equals 3. 3 multiplied by 180 equals 540. Therefore, the angles in a pentagon need to add up to 540 degrees. Let's use this information to calculate the missing angle in this pentagon. We can see that this polygon has 5 sides and 5 angles. Let's check what the angles need to total. 5 minus 2 equals 3. 3 multiplied by 180 equals 540 degrees. Pause the video while you work out the missing angle, then press play to check your answer. We can see that 3 of the angles are right angles, and the other angle is 135 degrees. When added together, this totals 405 degrees. To find the missing angle, we need to subtract 405 from 540. 540 minus 400 and 5 equals 135. The missing angle measures 135 degrees. Now it's your turn. Pause the video while you calculate the missing angle, then press play when you're ready to continue. Let's check your answer. Remember that all the angles in a 5-sided shape, or pentagon, add up to 540 degrees. For the next section of the video, you will need a protractor. We will now look at how we can use a protractor to help us measure the size of an angle. To measure angles accurately using a protractor, follow these steps. First, place the protractor. Position the midpoint of the protractor at the vertex, or point, of the angle. The midpoint is the cross in the middle of the protractor. Next, align the base line. Ensure one side of the angle aligns with the 0 line on the protractor. Some protractors will not show a 0. Instead, they will show 360 degrees. If this is the case, align one side of the angle with the 360 line. This is shown using a red line in the diagram. Finally, read the angle. Look at the other side of the angle and read the number that the line runs up. In the example on screen, you can see that the other side of the angle, the blue line, reads 109 degrees on the protractor. Angle H measures 109 degrees. Remember to double-check your reading to make sure the protractor hasn't moved. You also need to make sure you're reading the correct scale, either inner or outer. Use a protractor to measure the internal angle below. This may be difficult on screen. Therefore, the following 2 questions have been included as practice questions in the workbook. Pause the video while you work out the answer, then press play when you're ready to continue. According to this protractor, the answer is 120 degrees. Use a protractor to measure the internal angle Z on the shape below. Pause the video while you work out the answer, then press play when you're ready to continue. According to this protractor, the answer is 76 degrees. "3D coordinates are used to specify the location of a point in a 3-dimensional space. 2D coordinates have 2 values, x and y. However, 3D coordinates have 3 values, x, y, and z. Let's recap the axes. The x-axis is the horizontal axis. The y-axis is the vertical axis. The z-axis is the axis that comes out of, or goes into, the plane formed by the x and y axes. It is perpendicular to both the x and y axes. The origin is the point where all 3 axes meet or intersect. It is always denoted as 0, 0, 0. It is always written with the x-coordinate first, the y-coordinate in the middle, and the z-coordinate at the end. A point in 3D space is represented by an ordered triplet,
x, y, z,
where x is the distance along the x-axis, y is the distance along the y-axis, and z is the distance along the z-axis. Let's look at an example. Find the missing coordinates of point D. First, we need to make a list of all the known coordinates.
A equals 0, 0, 0.
B equals 5, 0, 0. C equals 5, 0, 5. We do not know point D. E equals 0, 5, 0, 0. F equals 5, 5, 0. G equals 5, 5, 5. H equals 0, 5, 5. Then, we can look at all the combinations and find the missing coordinates of point D. Let's look at D. It may help you to visualize the cube head-on. Point D has not moved left or right from the start of the x-axis. Therefore, the first coordinate is 0. It has also not moved up from the y-axis. It is still on the same level as point A. Therefore, the second coordinate is 0. Finally, when we look at the z-axis, we can see that point D has more depth. It has moved backwards, so the z-coordinate is 5. Point D's coordinates are 0, 0, 0, 5. Now it's your turn. Find the missing coordinates of point G. Pause the video while you work out the answer, then press play when you're ready to continue. Let's check your answer. First, make a list of all the known coordinates to help you. Then, find the missing coordinates of point G, which is 1, 1, 1. You should now be able to calculate the sum of angles in various shapes, measure angles using a protractor, and find missing coordinates of 3D shapes. I hope that you've enjoyed this video. Thank you for watching. Goodbye.